Interrealm is a specification in Gno that adds a syntax to explicit the realm context modification. It protects users by avoiding implicit realm scope modification that could lead to unseen reentrancy attack. Let's see what is it, highlight the security benefits, and understand the interrealm behavior. A realm is an isolated mutable state space within the Gno VM. Each realm has its own storage, which comes with its own global variable. It controls its mutation access through its own realm context, which means if you want to modify any storage or any states, you really have to get through its own context and has its own dedicated coin address. At the opposite, pure packages don't have any local states, so they don't have any storage. Here is the flow for a realm method call. Gno is a multi-context virtual machine, which means each realm is fully isolated and self-governed, like a container. It is represented by the yellow square. To do an actions, you will need to do a context change, which can be compared to machine context in distributed computing. If I want to modify the realm B state, I will have to get through its context. When it's finished, I'm getting back to the realm A. This creates a provenance tag, which can be accessed through some functions in Gno, which are current realm, previous realm, and origin color. Pure packages, since they have no states, are executed in the color context. So if you do a current realm in a package, it will be equal to the realm A address. This design installs a crucial flaw, which is really known in smart contract, which is reentrancy attack. Let's say a user calls a malicious contract. This contract will call a withdraw of a vulnerable contract, which will then send GNOTs. At that time, the vulnerable contract is not supposed to send again the funds, but this funds is only updated when we finish the executions, which means we can again withdraw and the vulnerable contract will still have money, which we will send again and again and again until the contract is empty. This can lead some malicious users to empty an entire contract by themselves. That's what happened in the DAO of Ethereum, which end up in a disputable fork leading to Ethereum Classic and Ethereum. Gno.land introduced a security which is called borrowing. It is a less permissive call for more secure environments. Borrowing basically lets you call a method on an external realm object, and at that time you temporarily enter the object storage realm. You cannot modify a global state, but you can modify the receiver object itself and object reachable from the receivers. If we go back on our reentrancy attack, you won't be able to send any funds since it is a global state, so you will have to go through a more permissive call. Its flow is simple. If you borrow the realm B object, it will be in the realm A scope, and you will only have access to limited storage of realm B. Secondly, you have crossing, which explicitly switch into another realm. With any crossing, you can gain full write access to the realm global storage like it used to be, and it is used for creating new objects or performing realm-specific logic. So if we do any crossing, this time with an explicit syntax, we'll find back the initial flow. To cross to any functions, you will have to add the word cross in parameter and add it in the parameter of the functions. Borrowing and crossing won't secure your realm directly, but it will avoid using too much write when you don't need to. And when there is a high permissions use, it is highlighted by the crossing keyword. Borrowing cannot create any unattached objects. There is no permanent realm context change. We only have a temporary for the method executions, whereas crossing permanently gets you inside the realm context, where at this time you can do anything inside. And the syntax is by default for borrowing and explicit with crossing. Here is two realm examples. In the first one, we did a borrow. We want to set the title of the new book, so we have to get through a method. We'll be able to modify the realm, but it is like an API. Whereas crossing, you can directly create a users and do whatever you want in the realm B. In that two examples, borrowing will act like an API, whereas crossing, you literally go inside the machine. If we take the code of the crossing at the bottom and we try to borrow it instead, it will not work since we won't have enough permissions. In summary, a realm is an isolated code which can only be accessed in its own current scope. Borrowing lets you temporarily access a limited scope, generally of an object, and crossing explicitly change the realm context for full access, which can go by the modification of public object. Choose the right approach for security and clarity so you don't use too much permissions when you don't need. Thank you for listening and see you next time.